This lesson is on domain and range and transformations. All of this is a review from Math 2 and Math 3. None of it's new. If I'm going too fast, please just pause the video and catch up, or you're welcome to rewind it at any time, but I am going to go pretty quickly through here. All right, inequality notation is expressions using the 6 inequality symbols, which are less than, greater than, less than or equal to, greater than or equal to, equals, and not equals. Interval notation is when you rewrite inequalities using numbers and positive infinity and negative infinity. You also use grouping symbols such as brackets or parentheses. Brackets represent closed dots on a number line or underlined inequalities. What do I mean by underlined inequalities? The less than or equal to, greater than or equal to, or equals. Parentheses are open dots and not underlined inequalities. All right, so that would be less than, greater than, or not equals to. And if you have more than one interval or area of shading, you must use the union symbol. All right, now's a great time to pause the video if you need more time to catch up. All right, so here we have x is greater than 2. X is greater than 2. So since it's not equal to 2, it's just greater than 2, that would be an open circle. So I'm going to jump over here to the number line. And if it's greater than 2, it's everything to the right. All right, to put that in interval notation, if it's not equal to, you use a parenthesis, and it's starting at 2, and it's going towards positive infinity. So this direction is positive infinity. All right, this next one, x is less than or equal to negative 1. Since it's equal to negative 1, we used a closed dot. And since it's less than, it goes to the left. All right, for this one, you always read the graph from left to right. So this one goes from negative infinity. The infinities will always have a parentheses with them to negative 1. And you use a bracket if it's a closed dot. Okay, the next one, negative 4, x is between negative 4 and 0. So at negative 4, I put an open circle because it doesn't have a line underneath it, and I put a closed circle at 0. And x is between them. So I shade in between. For this interval, I'm going to do a parenthesis for negative 4 because it doesn't have a line underneath, and then a bracket at 0. All right, all real numbers would be the whole entire number line. So that goes from negative infinity to positive infinity. Once again, you always use parentheses beside of infinity signs. You too. Okay, this one means all real numbers except x cannot equal negative 3. So I'm going to shade the whole number line but negative 3. All right, so this one you have two separate things you have to write. So you go from negative infinity to negative 3, and you use a parentheses because it can't be negative 3. And then you're going to use a union symbol, and it's going to go from negative 3 to infinity. So this is negative infinity to negative 3, and then negative 3 to positive infinity. All right, x is less than negative 2, so I put an open circle at negative 2, and it goes to the left. Or x is greater than or equal to 1, so that one gets a closed circle and goes to the right. So once again, this one, since it has two different parts that are shaded, we're going to have two separate intervals. So negative infinity to negative 2, parentheses, union. Oh, this one has to have a bracket. because it is a closed circle at 1 to infinity. So you can have a bracket on one side and a parenthesis on the other. That's completely allowed. All right, and the last one, x is greater than -3. So closed circle at -3. But it can't be equal to 0. So an open circle at 0, and then we keep going. So once again, we're going to have two separate things. So bracket -3 to 0, parentheses, because an open circle at 0, union 0 to infinity. Okay. All right, the domain of a graph. Again, review from Math 2 and Math 3. You did this already. It's all x values. The domain is the x values. And you look left to right on the graph to get those. The range is the set of all y values. And you look bottom to top. Okay, so let's look at this function right here. And the domain, you go from left to right. So it goes to the left forever and the right forever. So that's -infinity to positive infinity. The range, you look from bottom to top. So if you look at the bottom, it starts at -4, and there is a point there, and it goes up to positive infinity. All right, this next one, domain, you look left to right. So on the left, it starts at -4, and it's an open circle, so you use a parenthesis. And to the right, it goes to positive infinity. For the range, you look from bottom to top. So at the bottom, remember this is your y values. So it is at -2 to infinity. All right, example 2C, domain, you look from left to right. So it goes to the left forever, and it goes to the right forever. The range, you look from bottom to top. Well, it goes to the bottom forever, so that's -infinity, and it stops at 3. Okay. All right, domain for example 2D, left to right. So on the left, it's -4. Remember, you're looking at the x values for domain. So it goes from -4 bracket to 2 parentheses. And the range goes from bottom to top, so -3 to 3. And look at your open and closed circles. Okay. Again, pause the video if you need to. All right. All right, transformations. These are a review as well. So a quadratic makes a parabola. It's a U that opens up. And that equation is y equals x squared. The domain, go from left to right, so it goes from -infinity to positive infinity. And the range goes from 0 to infinity. All right, a cubic looks like this. And its equation is y equals x cubed. And the domain, it goes from left to right forever, -infinity to positive infinity. And the range, it goes from bottom to top forever, so -infinity to positive infinity. All right, absolute value makes a V, just like the first letter of value, so it makes a V. That equation is y equals the absolute value of x, so you use those bars. The domain, you look from left to right, so it goes from -infinity to positive infinity. And the range is 0 to infinity, bottom to top. All right, cube root looks a little weird. Looks like this one. And that's y equals the cube root of x. So there's a 3 on the outside of the root. All right, domain, -infinity to positive infinity. And the range, same thing, -infinity to positive infinity. It's hard to tell, but it will keep going down gradually forever, and it'll keep going up gradually forever. All right, and square root looks like this, and that's y equals the square root of x. So the domain, remember, you go from left to right, so it starts at 0 and goes to infinity. And then the range, you go from bottom to top, so 0 to infinity as well. Okay. All right, vertical translations. If you add or subtract a number at the end of your function, then this is what happens. If you add a number, it's going to go up d units on the graph. If you subtract a number, it's going to go down d units. Okay. All right, over here, horizontal, so that's left and right is what horizontal means. This is if you add or subtract a number inside the parentheses. So what I think you've heard before from your other teachers is if it's inside, think about it being inside jail, and the reason you're in jail is because you did the opposite of what you should have been doing. So plus C, a lot of students think that should be right C, but it's actually left C units. So just remember that when it's inside, it's the opposite of what you would think, because it's inside jail. It was doing the opposite of what it was supposed to be doing. Minus C means you go right C units. All right, once again, pause if you need to. All right, these directions say, draw the original parent function in black, state all transformations in the given function, graph the function based on its transformations in color, and state the domain and range using interval notation. Okay, so we'll start with the first direction. Draw the original parent function in black. So if you look at your function, it is an absolute value because it has the bars in it. So the parent function is just a v starting at 0, 0. That's what it means by the parent function, the ones we did at the top of the paper. All right, the transformations are what these numbers do. So plus 2 is inside, so that moves it left 2. And the 3 is on the outside, and it's minus 3, so it moves it down 3. All right, now we're going to graph the transformations in color. So I'm going to use red. So you need to start here at 0, 0 and go left 2 and down 3, and then draw a new V. Okay. All right, the domain, we're doing the red V. The domain of the red V, so from left to right, negative infinity to positive infinity. And from bottom to top, it's negative 3 to infinity. Okay, this next one, since it has a 3 on the outside, it's cube. It's the cubic function. So if you look up at the top of your paper, that one looks like this. You're going to do that in black or in pencil. All right, now let's talk about the transformations. What do these numbers do? So minus 3 is inside, so that moves it right 3. And plus 1 is on the outside, so it moves it up 1. So start at 0, 0 and go right 3 and up 1, and then draw your new curve through that. Okay, we're going to do the domain and range of the red curve. So the domain, it actually does go left or right forever, and it does go up and down forever. All right, and the last one. This is a square root, because that's what it has in it. So it's a square root function. So if you look at the top of your paper, the square root function looks like that. The transformations, the plus 2 is inside the square root, so it moves it left 2. and the plus 2 is on the outside, so it moves it up 2. So you start at 0, 0, and you go left 2, up 2, and then you kind of just copy it. All right, let's do the domain and range of the red. So the domain is from left to right, and it's the x values. So it starts on the left at -2 if you look at the x-axis, and that's a bracket, and it goes all the way to the right to infinity. The range is your y values, so you've got to look at the y number, which is +2, and then it goes up forever to infinity. All right, feel free to go back and watch any part of this video that you did not understand. Hearing it a second time will help.